Learning never ends at McMaster. Welcome to an opportunity to engage your curiosity from the comfort of your own environment. This online series is sponsored by the McMaster Alumni Association as part of our goal to connect with our global alumni and their curious minds.
Hello and welcome. My name is Greg Zilberbrant. I am the program lead for Carbon Mitigation and Circular Economy program here at McMaster University. Thank you for joining us today for another episode of The Curious Mind. Today I want to talk to you about circular economy, give you a practical understanding of the concept and how it ties to sustainability. So let's get started. So circular economy is something that you would have heard about, maybe read about in the news, have seen on social media, or have seen discussed in different public policy sectors. A lot of time it's tied to zero waste. You may have heard of the plastics ban that's happening here in Canada and around the world in different jurisdictions. So this ties into a higher overarching sort of umbrella concept of circular economy. So let's start on what is circular economy and how do we understand it? How do we tie it to our concepts of sustainability here in Canada and around the world? So first of all, what it is not. It is not simply taking your blue bin to the curb. As important as that is, as important as recycling is, it is a starting point. Circular economy is a much broader concept. Recycling, of course, is part of that, and the reuse of materials and the ability to recapture those resources is very important for circular economy. But this is only the starting point. It's the tip of the iceberg. So going back to what is the concept of it? And this is really, when we talk about circular economy, we're talking about changing the way that our systems operate. Right now, we move through a linear system. We take material out of the ground. Most of our resources come out of the ground in some way, shape, or form. We manufacture it into something that we need. Once we use it, then we dispose of it. This has been our system for a long period of time. And the challenge that we have is, of course, it requires additional resources coming in from the front end of the system, and it requires disposal at the back end of the system. And this is what we have seen for decades, for a couple of centuries now in our industrial system. The focus now is to shift that system, and really it's to transition that system into something that is not linear, but rather circular. And that's where the concept circular economy comes in. So we still are making things, we are still using things, but the focus now is, can we return those resources back into our systems so we can use them again? So this is where recycling does connect very strongly to circular economy, but recycling doesn't necessarily lead to those materials being used in the best way, nor does it make the most sense. As you can appreciate, even recycling in its own hierarchy is reduce, reuse, recycle. It's at the bottom of that waste hierarchy, of course, disposal being at the very end. So how do we look at it from a systemic standpoint as to how materials move through? So circular economy, again, we're starting with this concept, as you see at the top of your screen, extraction of raw materials. We're taking something and we're manufacturing it, and that's the next step. We design it and we produce something. And this is really important, this design step. Right now, this is part of the challenge that we're discussing, because when we talk about recycling, we're talking about the step after our use. What we need to start talking about, and where the circular economy really comes in, is in the design stage. The design, the production. How are we actually manufacturing things so that they can remain in this loop? So we're not designing them for the dump. We're not designing them to be disposed. We're designing them to be reused, whether they're as a full material or as resources or minerals of that material. Then we get into packaging and distribution, and this is, of course, part of the big discussion right now with aspects such as single-use plastics or single-use packaging or disposable packaging. What we're trying to get away from, obviously, what are useful things actually come in, and then the packaging then going to disposal. Finally, use and maintenance is our own, obviously, enjoyment of those materials, those resources, and then finally we get into disposal. And this is where the circular economy really comes in at the back end of the system. So we talk about the design, the front end of the system, we're considering the packaging, we're considering the use, but at the back end of the system, this is where we need to decide how we're able to recover those resources, how we're able to put them back into the raw material streams, either back into the same products that they were before, or we're able to break them down to components that go into different products, or we're able to actually break them down into their constituents, their mineral compounds, what makes up that material, and then send it back into different systems, whether it's the same product or a different product. Our goal is to eliminate as much as possible, and I would say eliminate, but reduce as much as possible realistically, are incineration and landfilling. So if we can eliminate it, then we have a perfect circular economy. If we are able to reduce natural resource input, of course, that's also our effort with the circular economy. Now, that comes into play only if we're using the same amount of products, the same amount of materials, so that also ties back to consumption. So we may be using more natural resources, but if we're bringing resources that are part of a system, part of a product back into that loop, we're eliminating the need for to extract the full amount of those natural resources and made the product in the first place. So what is the challenge? Why are we talking about this? Because we need to understand why we're talking about this issue and why it's such a big movement, why there's so much discussion of it. So this is the global challenge. And I would express it as a global challenge and opportunity, because any time that we get into these situations where we need some sort of monumental shift, some sort of change in our thinking, there is an opportunity that is available to us, to not only from an environmental standpoint, from an economic standpoint, and a social benefits standpoint, what we want to achieve. And you can see throughout the world, the OECD countries, so the developed countries of the world, their consumption of, if you go from top to bottom, biomass, fossil fuels, metals, and non-metallic minerals. Non-metallic minerals tends to refer to building materials. So you can appreciate, if you're watching this video, that you're probably sitting in a room, you're surrounded by some amount of concrete or bricks. There's a sidewalk outside. There are storm sewer pipes that are taking water away. They're all made of these non-metallic minerals that are all around us in our developed world. So we see that as the world economy grows and as the social benefit of different parts of the world grow, and as communities and jurisdictions become more developed, they of course consume more materials to reach that level. And we can see that as the developed countries are starting to slow down a little bit, we can see the BRICS, the Brazil, Russia, India, Indonesia, China, and South Africa is still growing. And of course the rest of the world, which is the developing world, we can see a significant growth in all that material consumption. So we need that material. We want that social progress. We want that economic progress for the world. The question is, how do we achieve that, knowing that we are living in a world of limited resources with environmental pressures that restrict our ability to simply do things the way we may have done them a couple hundred years ago without much thought into the long-term environmental impacts. So what we're trying to achieve is this decoupling of material extraction from economic and social progress. So the decoupling of material extraction, meaning that we want economic and social progress, it doesn't necessarily have to be tied to our material extraction, our raw material, the non-renewable raw material extraction. So we want to separate those two. So we want economic and social progress around the world for everybody, but can we do it in a way that doesn't require us, to extract new non-renewable raw materials to achieve that benefit. The same thing goes for greenhouse gas emissions. Of course, one of the major pressures that we have in our world is the climate change emergency. So can we decouple this? And we need to decouple our greenhouse gases from our economic growth. But this is a challenge because as we use more and more materials, of course, we have this impact on greenhouse gas emissions, energy consumption, in order to achieve that. So now we're trying to decouple greenhouse gases from economic and social progress, which is a challenge in itself and not to be minimized in any way, shape, or form. And circular economy can help that. It's not the silver bullet. It's not the solution to everything, but it can take us a long way if we're able to reduce our energy consumption and our greenhouse gas inputs into materials, into productions systems, and also into the resources that are being wasted. And finally, this elimination of waste, which is critically important. Landfills are not something that we necessarily want. It's something that we still very much need, unfortunately. And we've got all kinds of waste management technologies to try to minimize how much waste goes to landfills or other, or energy from waste facilities or incineration. But we're trying to reduce the amount of waste and try to really eliminate that waste. So everything becomes a resource. Everything that we've created in the world is a resource. We put energy into it, we put materials into it, we put effort into it, we put thought, design into it. So to have those resources now be wasted is unfortunate. So this is when we talk about embodied resources. So everything we have in our world has some embodied resource, has embodied materials, has embodied energy, has embodied greenhouse gases, which means that we use those elements in order to create that resource. So we don't want to waste it. We want to recover as much of it as possible. So the question is, why can't we just improve our old linear system? Isn't efficiency great? Efficiency is exceptionally important. Some of the biggest levers that we have for our operations, for our industrial systems, for our energy systems, are really tied to efficiencies. But we have to think of it from a different standpoint, and we have to change the way we think about our design and to change the way that we think about our systems. So I have for you here on our map, of course, McMaster University, which is our starting point, and I've made it the center of the earth, of course, in this picture. And we've got 2 points. We've got Kingston and we've got Windsor, and approximately the same distance. So right now, the analogy I will use for you is we are on our way to Windsor. And we're driving 100 kilometers an hour on the 401 highway running through Ontario. So we're moving at 100 kilometers an hour, and we want to become more efficient. So if we become 10% more efficient, we will be going 90 kilometers an hour, 20%, 80 kilometers an hour, et cetera. So at what point of that efficiency will we reach Kingston? If we improve our efficiency in these terms, whether it's 10%, 20%, 30%, 50%, at what point will we reach Kingston as we're driving towards Windsor? And the answer is we won't. Right? We have to turn the car around. And that's the analogy when we talk about circular economy and we talk about eco-effectiveness versus eco-efficiency. Efficiency is very important. We need to slow the car down so we don't get to Windsor and we reach a point of no return. We need to turn the car around and start heading the other way. And I apologize, this is my example simply from a distance standpoint. I mean, no offense to Windsor in terms of the direction that we're heading. It's simply an analogy to say if we're heading in this direction, we need to turn the car around. And this is the thought change that we need to have across businesses, across policy, in order to achieve this. So what does this look like? And why isn't it everywhere if it makes so much sense? Well, there's a few challenges. One is the approach. There's a number of things that we can do, and it's not necessarily very straightforward. The challenge that we have is measuring what is true circularity. So are we talking about how much material stays in the system? Are we talking about how many uses we get out of certain material? Are we talking about the ease of recycling and repurposing those materials? Are we talking about the ability to dismantle those products into their components and use them again? And sometimes that's not necessarily logical. So we might not be making materials that are lighter weight. We might be making things that are heavier, which might go against our previous logic of the products that we make. But now that it's heavier, the material that we use is more recyclable, or we can recover a higher percentage. So this is the challenge. So this is the discussion that occurs a lot in circular economy circles, is trying to create an approach that makes sense for everybody. And frankly, right now there isn't one. And this is why it's more of an umbrella term rather than something that is concrete that you can define and say, yes, this is exactly circular economy. This is what it is. And that leads me to my second point, which is a definition. There are, I believe as of 2 years ago, there were about 114 different definitions that were published of circular economy that were published either in some sort of academic journal or in trade journals. So you can appreciate that this is part of the challenge. If we've got so many definitions, what does it actually mean? And the final one is hierarchy. And I've put a few images up here. These are from Ellen MacArthur Foundation, which is a leading organization on circular economy and a think tank and really pushing the circular economy agenda in a very positive way. And I've got a couple others for you up there that are from the World Economic Forum and the OECD. And you can see that the terminology is more or less the same. Resource recovery, reverse cycles, sharing, new business models, so a sharing economy, new business models. And you've got the image in the middle that shows a bit of a hierarchy that shows, we want to reuse things because that requires the least amount of energy input or material input, and then we can repair and refurbish, then repurpose, remanufacture, and finally recycle. So again, we're not going that far away from the waste management hierarchy. We are really staying within that field, but we're adding elements to it to show that there's all these steps that we can take that benefit circular economy, benefit environmental impact, whether that be greenhouse gas impact, whether that be material use, or in general energy requirements. So let me simplify it from a very practical standpoint. We've got these outer circles, and these outer circles are the areas that exist to a certain degree at the edge of circular economy. So disposal, of course, is our last choice. We don't want disposal. It's still necessary for some materials and will remain necessary in the foreseeable future. The one inside that is slightly better, which is energy recovery. So if we can't do anything with material, can we at least recover the energy? Can we recover the energy in some format, whether that be in an energy from waste facility, whether that be an industrial system that requires thermal energy that we can now substitute a non-renewable resource that we were otherwise using. So this is an opportunity. The next one that we have in this yellow circle is reverse cycles. So this is our ability to actually capture materials that exist within the recycling world, that exist within a system that could provide us raw materials for our products. So this reverse cycles is really our recycling system. But it's a little bit more than that, because it's not just about recycling and then taking the product back that's available based on the expectation of being recycled. But it's actually going into those situations where you're able to retrieve materials that otherwise would have been disposed of and there is no system for. So it's actively seeking that out. So it's recycling the traditional way, but it's also seeking out materials that are currently wasted and trying to integrate them into design. And in the middle, we've got a few examples of circular economy models, if you will. So the one at the top is circular design. This is probably the most important one, because if we have circular design, then we have materials that come back through the same system through and through, and we can really start to get rid of those outer circles. The one next to that is business models. This is where we're looking at our ability to maximize the material, energy, or carbon input per unit of service. So in other words, can we change the way that we approach our business models and deliver them in a way that allows people to still have access to products or services, but we maximize how much that's used? And we can see, of course, that a big part of that is the sharing economy. So individuals' ability to use a vehicle that is, rent a vehicle that is sitting in a parking lot and have access to a vehicle rather than owning the vehicle. So that vehicle ends up being used more because there's a number of owners or a number of users rather than one individual. Vehicles are these wonderful things that sit somewhere for about 23 hours a day and then move for maybe an hour or two. So this is one way that we can do it, is maximize that. And then industrial ecology is this area which is sometimes referred to as the science of sustainability. This is where we're taking industrial systems and trying to actually improve the impact, environmental impact on these systems. And a big part of that is referred to as industrial symbiosis. Industrial symbiosis is the exchange of materials, using one material from an industry that might be waste as a feedstock for another. And if we can do that, we start to find that within industrial systems, we're actually able to recover waste materials and use them as raw materials for another system. So let me give you a few quick examples, just so you understand the reality of what's happening in this area. So one example is actually a manufacturing facility here in Ontario, in Stratford, Ontario. They have the availability of high-density polyethylene material from post-consumer products, which is in the form of bottle caps. What they do is they crush them, they shape them, they mold them, and they actually make furniture. So the picture that you have there, Muskoka chairs, rather than disposing of that material or purchasing raw material, raw plastic, they actually bring it back and manufacture a high-value product from something that would have been either used sparingly or might have been tough to find an outlet for, or would have been disposed. And this is important because it's post-consumer. It's not post-industrial. This is actually coming from the recycling system. And if you see, I put a little star for you there, just to show approximately where it would land within this radar graph that we have up there. The next one that we have is a popular service called Rent the Runway. There's an outlet in Toronto where you can actually go and try on dresses. You can rent a dress for an event, and they can return it after. So rather than buying dresses, rather than buying a one-off piece of fashion for an event, you can actually go and rent something, use it, and then return it. So of course, as you can appreciate, then it gets a lot more wear. So the same thing, obviously exists for for individuals who want to rent a tuxedo or a suit for an event, same idea, but for dresses. And this offers a service, and this is the idea of this product as a service. The next one that we have is an interesting company out of the US, and they're actually growing their packaging material. So they grow packaging material with a fungal network and use of agricultural waste. And they grow these different shapes depending on their customers' needs. And so what happens is they've now got a compostable packaging material that can be designed into any shape and can be used for any product. And then it just goes back in the compost facility because it started as agricultural waste, and it's frankly just agricultural waste, and it's the same fungal network that is similar to mushrooms. So again, it's compostable and can be part of that continuous cycle. So we've got a few of these areas, and we've just skimmed the surface, as you can appreciate, as an introduction. So there's a few areas that we focus on, and the first one is, can we design waste out of the system? And this is the concept of cradle to cradle, which is a very sort of foundational concept within circular economy, written at the time by Bill McDonough and Michael Bruntgard, to exemplify what we can do if we move in this direction. So cradle to cradle, and this concept of waste equals food. So can we take waste from one space and create food for another? So similar to the way that nature does it. Can we create a system that is linear, a system that is circular, system that is continuous, that allows this byproduct of one area to become the primary feedstock of another. So the goal is then we design the waste out of the system in the first place. We don't even have to deal with it because it's a circular system in itself. The next one is to keep products and materials in the system. And the concepts that we have, a couple of concepts we have in that area, are design for disassembly and modular design, which is very much what it sounds like. Design for disassembly is, are we able to disassemble this easily? So it's not about disassembly in general, it's about disassembling easy. Can the average person or someone with not a significant amount of skill or a significant amount of tools or resources available to them, can they disassemble it? And then those materials can then go back into various inputs for design for other products. The next one is modular design, and this is a tough one, but an important one again. Can we upgrade things? Of course, one of the toughest areas for this is electronics. Can we upgrade things? Rather than buying the next iPhone, can we upgrade our previous iPhone and have the same features, have the same speed, have the same ability to communicate with the world the way that we want to and keep up with that technology, but not necessarily have to buy a new package and a new phone with all the parts. So if we can do that, that obviously helps all the things up higher on that on the list. And finally, we have this products as a service, or this concept of usership, which is what I mentioned with the car leasing services or the partial ownership into a system, or a membership into a system. So the best way to describe that is the quote that I have there, which is, nobody needs a drill, they need a hole in the wall. So we don't need a car, we need to get from point A to point B. So we don't need the actual physical thing, we need the service that it provides. And this is where some companies are being very thoughtful about, can they provide their products as a service and create this concept of usership rather than ownership. So I hope that was informative. We'll post some links to other examples of organizations doing great things here in Ontario, around the world, with some more case studies that you can explore on your own. And this video actually will be recorded, and you can rewatch it, and there will be a survey that goes out, and we hope that you share with your friends who also have an interest in this area, and we hope you join us next time for another feature of The Curious Mind. Thank you.
This online series is sponsored by the McMaster Alumni Association as part of our goal to connect with our global alumni and their curious minds.